Okay, welcome to my other video. As you can see here, I have 750 watt power supply on my PC, and today we're going to take a look at the inside of 1200 VA UPS. It's a KRISBOW Pro series. I have a window film here with the tape, because the LCD doesn't look pretty good, so I have to stick a piece of, like filter, so the unlighted LCD will not show. So let's unplug it and see what's inside. Okay, so here's the UPS on my desk. As it says 1200 VA. Oh my god, this is quite heavy. You can see, where is it? 1200 VA. Let's see if it's focused. I don't know if it's visible or not. Let's check my camera first. Yes. It's 1200 VA, 220 VAC, 50 Hz, and the same with the output. Fuse 6.3 amps. So let's take a look inside. The problem with these things is that even with only 750 watts power supply, on this display it has current measuring, the load on it in percent. Under full load on my both GPU, it will say overloaded. Wait a second, I left my screwdriver somewhere. Okay, I'll be right back. Okay, I'm back. So, but first, before I open it up, let's see what the output waveform looks like. So here, move it away. My laptop right here. And here's my homemade probe. I have a video on how to make this. So for this test, I didn't connect anything to it, no charger or anything. So take a little bit up. Focus it. Great. Let's open the software. Is it so dark? Okay, I have to charge it. We just want to see the waveform, what does it looks like, everything. So let's turn this all the way down, connect this. Be careful not to touch this because it's a 220 volts here, so a bit far away from our hands could get. And let's see if it does. Okay, it does works. There's a line if you can see. Let's power it up. There it is. The UPS powering up. And take a look at that. I'll use my screwdriver slowly increase the gain. I'm gonna touch it by hand and then touch the metal parts of this laptop because it might be the same ground reference as this UPS, so you might get an electric shock. And there you have it. It looks like a modified sine. It's a modified sine. Just turn it off. Okay, it's off. Pull it up for safety. Okay, tidy up everything. Let's just move it away. Now we can begin opening this UPS and see what's inside. So this is the UPS. So let's put it. How do I start opening it? Maybe I'll stop here. God damn it, it's quite hard to open. Let's take it away so we didn't lose it. I can barely see a transformer in it. Looks like quite big. Let's open it up. Remove all the screws. Shit. Take it to the other side. This thing is still quite warm. It's been running for like 5 months or so. And oh yeah, I just bought a new phone. It's a Galaxy Note. It's quite a good phone, yeah. Open it up. Okay, here comes the inside. So take a look at this. Let's zoom it in. Come on, where's the zoom? So let's see. Here's the main control board. So unplug the transformer. Just in case something goes wrong. So here's the Mosfet that drives the modified sine wave inverter, and here's the cable to the LCD, and looks like this one is connected to, let's see, what is this? Oh, looks like the front button. And here are the 3 Mosfet. Let's take a look at this. What's the number? It's a 50N06. Yep. 50N06. Shit. It's a 50 amp 60 volts if I'm not mistaken. Oh, this one they have 250 N06 with one LM317. Interesting. How did they do that? Well, this only have 2 MOSFET, this one has 3. And let's see, this one connected directly to the transformer. Yep. And the center tap of, wow, look at this wire. It's huge, and look at that. And the center tap of it is connected directly to the positive. Nice. So let's take a look deeper. Oh, they make it. This one have 3 and this one have 2 MOSFETs. God damn it, I dropped it. Okay. Okay, don't stress the board. I don't want to destroy it. So if you press a board too hard, you might end up break it. And let's see what else inside. It's only this battery and transformer, this main control board. I think it is. Let's take a look. Okay, so here's the control board. Oh, look at that. It's quite a thick wire. Okay, it's connected to the negative. Oh, shit. Okay, it's connected to the negative, and let's see. This one, looks like the source pin. Yep. Mostly the source pin connected to all these MOSFETs. Wait, this one's also 50N06. They put one LM317 right here. It will be more like unbalanced, I think. I don't know. can tell it will be unbalanced if you put only 2 right here and 3 right here. Usually one of these will, like this one will get much hotter than this. Now let's see if all this MOSFET connected in parallel. Wait. Okay, this one's not connected in parallel. So I guess the only MOSFET that will drive the transformers here. Oh, it's quite huge. It's big and heavy. Okay, they only have 2 pairs of MOSFETs. This one's not used for inverter, as you can see. It has separator. It's not connected to this heatsink anyway. And yes, they're not connected together except this one's a charging MOSFET, I guess. See the source connected to this. What is this? Resistor. And oh yes, this one's a charging resistor, and this is the LM317. Looks like to control the charging, so it will not overcharge the battery. Quite a nice design. So I guess they use PWM control on charging the battery. And let's see, offline UPS, and it has 4 relay right here. I wonder where's the current measurement shunt. Interesting. It could measure current, but how did they do that? The mains input will go to the fuse and go to the circuit. It's connected right here, so it go into this end. What is this? So this jumper bridge, I guess, and directly into the relay. The output will be here and here. Okay, so yes, stepping or whatever we call it. Oh yes, this is it. Oh, wait, it's not. Is it? Okay, so here's see, here's the current measuring transformer. Okay, shit. So here's the 1 turns of thick wire, which is being passed by an AC power, and here's the pickup coil. So it's basically a transformer. It's a current transformer. Yep, and all the relays 24 except this one. This one is 24 volts, 24. This one's 12 volts DC, and it's quite a nice design. Look at that board, and look at this. They even put it here to handle the current of this inverter. Quite a nice. What's this chip? You can see it. What's this? Come on, it's a bit dirty. Come on. It's made by, let's see, Higher. Yep, Higher. It's a, let's see. Come on. Can get it clean. Let's see, what's this? It's like, start with, okay, let's, what the hell with these things? It's adhesive. I'll get a tissue for a second. See if we can clean it with this paper towel. I guess it's much better now. Still can't see it. Okay, it's visible. It's a HR6P73 P8 dBl. And okay, it's a HR6P73 P8 dBl. Let's go ahead and search it on Google. I'm curious what kind of chip is this. HR6, let's enter it. 6 P73 P73 P8 DBL. Let's see what kind of, it's found here. Let's see what kind of chip is this. Yep, it's a Shanghai high air integrated circuit. There's data sheet on it. I'm curious what kind of chip is this. It doesn't say anything about it. But looks like, what is this? Let's see the pinout. It looks like it's a single. Okay, it's an oscillator IC. Check out it has OIC1, OIC2, and what's this PB? Oh, I don't really understand what this. Let's see. They're available. It's available in DG key. Nope, it's not. Okay. I know. I can't find the part number for this, but I guess it's a single oscillator. It's designed for this kind of inverter application. It outputs modified sine. Not really bad. Let's remove it and see what else inside. So the battery is a pair of 12 volts 7.0 amp hour battery. Okay, let's put it down. It doesn't say anything about the transformer, but it does say 29.5. Looks like this one's for charging the battery. And 15 ohm and 15. And the other is just an output. Okay, it's an output. Let's just connect it to this Mosfet. So the battery is 24 volts, 7.0 amp hours. What brand is it? Let's see, is this Ritar? R-I-T-A-R? More like retard. So that's all, I guess. And here's the LCD board. It's a cheap on-board design. No part number on it. And yes, these two wires is coming from this front power button. Okay. Quite a nice design. So anyway, I don't know how to fix this, because it does say 1200 VA. According to the calculation, if I use power factor 1, it should be able to put out 1200 watts. But yeah, I don't know. And the other things is that my power supply does say it has power factor correction. Let's check the boxes. I don't know if PFC stands for power factor correction. I'm not quite sure. Where is it? I need to find the PFC. Where is it? Last time I read this box, it does say there's a PFC in it. So, should be able to fix the power factor. I don't know. Where is it? I don't know. But it does have say We have PFC in it. Come on, where is it? Okay, I can't find it right now. But it should have it. And by the way, anyway, all this kind of switching power supply would have PFC since they turn it to DC and have a capacitor in it. So yeah, I'll just put it back and continue using it. Maybe I'll just hack these things to make it, you know, detects lower current. So anyway, thanks for watching. See you next time. And as always, don't forget to subscribe. And if you have any suggestion for future video, leave in the comment. See you next time. Don't forget to subscribe.